Alright guys, today's lesson, the learner will understand how to graph linear equations. An example of equation in two variables is 2x plus 5y equals 8. A solution of an equation in two variables, x and y, is an ordered pair x comma y that produces a true statement when the values of x and y are substituted into the equation. So it says tell whether 4 comma negative 1/2 is the solution to x plus 2y equals 5. Okay, so what this tells us is x equals 4, y equals 1/2. So we know this. So when I take these values and I substitute it in over here, you're going to get 4 plus 2 times negative 1/2 equals 5. 4 plus negative 1. Is 3 equal to 5? No. So not a solution. Alright, so now graphs. The graphs of an equation in two variables is a set of points in a coordinate plane that represent all the solutions of the equation. If the variables in an equation represent real numbers, one way to graph the equation is to make a table of values. Plot enough points to recognize a pattern, and then connect the points. When making a table of values, choose convenient values of x that include negative values, 0, and positive values. Alright, so what I'm going to do is I'm going to substitute negative 2, 0, and positive 2. So I'm going to plug in y plus 3 times negative 2 equals negative 2. Y plus 3, negative 6 equals negative 2. Add the 6, you get y equals 4. Okay? Then I'm going to plug in the 0. Y equals y plus 3 times 0 equals negative 2. Well, 3 times 0 is 0, so y equals negative 2. Okay, now I'm going to plug in the 2. So you get y equals, there you go again, Mr. McGaw. Y plus 3 times 2 equals negative 2. Y plus 6 equals negative 2. Subtract the 6. Y equals 4. Negative 8. Negative 2 minus 6, negative 8. So now we can graph these points. So we go over to our graph. You graph the point 2, 1, 2, 1, 2, 3, 4. Or sorry, negative 2, comma 4. 0, negative 2, and then 2, 1, 2, 3, 4, 5, 6, so it would be down here. Connect the dots. Okay, so there we go. Let's take a look at some more. Alright. A linear equation is an equation whose graph is a line, such as the equation in example 2. The standard form of a linear equation, ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. Consider what happens when a equals 0 and b equals 0. So when a is 0, the equation becomes by equals c, or y equals c divided by b. Because c divided by b is a constant, you can write y equals b. Similarly, when b is 0, the equation is ax equals c, or x equals c divided by a, and you can write x equals a. So we have these two equations, y equals 2.5, x equals negative 4. So what we need to think about here is let's graph the y equals 2.5. So if I just start at 0, 0, and I think there's 0, there's 1, there's 2, there's 2.5. Well, if I go up, it's no longer 2.5. If I go down, it's no longer 2.5. But if I go left, I'm staying at 2.5. If I go right, I'm staying at 2.5. So when you get y equals, it's just a horizontal number at 2.5. Now let's take a look at the x equals negative 4. So now I'm going to be graphing x equals negative 4. So we look. Well, this is the y value, so x doesn't change when I move up or down. X, so negative 1, negative 2, negative 3, negative 4. Now if I keep moving this way, x is changing. If I go backwards, x is changing. But if I go up and down, x is not changing. So there's where x is negative 4. So it's a vertical line at x equals negative 4. So y equals a number is always a horizontal line. X equals a number is always a vertical line. Okay? Let's take a look at some more. All right. In example 3, y equals 2 is a function, while x equals 1 is not a function. The equation ax plus by equals c represents a linear function provided that b is not 0. That is, provided that the graph of the equation is not a vertical line. If the domain of a linear function is not specified, it is understood to be all real numbers. The domain can be restricted as shown in example 4. So let's take a look at our number 4. See how it's saying the domain is x is less than or equal to 0? Then identify the range. So what we need to do is graph this. So what we're going to do is 0, negative 1, negative 2. Graph 3 points. Why did I go 0, negative 1, negative 2? Because it says right here, x has to be less than or equal to 0. So start at 0, get smaller. If you plug in 0, y equals negative 3 times 0 plus 1. So it's 1. Y equals negative 3 times negative 1 plus 1. 4. Y equals negative 3 times 2 plus times negative 2 plus 1. 5. No. 3 times 2 is 6. Negative 3 times negative 2 is 6 plus 1 is 7. So now I have the points. 0, 1. Negative 1, 1, 2, 3, 4. Negative 2, 5, 6, 7. So the range. Well, what we have to look at here the range is talking about the y values. Okay? So y is starting at 1. Is it getting bigger or smaller? Is it getting smaller or bigger? Well, it's going up. So y is greater than or equal to 1. Okay? So remember, domain, all possible x values. Range, all possible y values. Okay? All right. Word problems. For gas that costs $2 per gallon, the equation C equals 2G gives the cost in dollars after pumping G gallons of gas. You plan to pump $10 worth of gas. Graph the function and identify its domain and range. Okay? So we're going to graph C equals 2G. Treat it like this. Y equals 2x. Now I'm going to graph 0, 1, and 2. Why am I graphing it this way? Because, can you put in negative gallons of gas? No. So if you plug in 0, you get 0. You get 2, you get 4. So if I graph these, I get 0, 0. I get 1, 2, 2, 4. And the line's going to look like this. So our domain, x greater than or equal to 0. Our range, y greater than or equal to 0, because they both go up. Okay? So there we go. If you were pumping $10 worth, you'd be getting 5 gallons, because if we look over here, the cost was $10, $2 per gallon. G equals 5 gallons. Because this was dollars and this was dollars. So the dollars cancel out, you're left with gallons. Okay? Alright. See you guys in class.